Hi everyone, welcome to our sensory lab in the COVID era. Under normal circumstances, we would do a few more tests and probably spread these labs out over 2 weeks so that we could do 1 week of somatic senses and another week of special senses. But for time's consideration and the fact that we are still in a protocol situation with COVID, we're going to go ahead and just do a sort of an abbreviated. But I think there's plenty to do with this week's lab. So we have the materials for you arranged on the back benches. So we're not going to be using any of the computers this week, but you can spread out, and I encourage you to do so if you have more than one working group in the lab at any given time. So what do we have on the table here? We have these eye covers. And you don't have to use the little screen there, that's not necessary. But what we want to do is use these eye covers instead of, or you can use your hands, that's fine, but the key thing is to don't close the eye that you're not using. You want to keep both eyes open as you're doing these visual acuity tests. And speaking of that, if you look on the floor here, there are actually two of these, you will see an orange piece of tape. That orange piece of tape is where you should stand roughly when you are doing the visual acuity test down the way. And on the right here for this one, we have the standard Snellen eye chart that also happens to be a color blindness chart. On the left there is our astigmatism chart. And so you're going to be doing both of those tests today or when you do the lab. A quick note about visual acuity tests. If you look at the number on the left of each line here, we're not talking about the astigmatism, we're talking about the visual acuity test. The top number is the number that the patient sees because we're measuring at 20 feet. So that orange line back there is at just approximately 20 feet. It's not exactly 20 feet, but it's close enough. The bottom one is the number that the average person with average visual acuity would be able to see that letter. So for that big red letter E there, you're seeing at 20 feet what a person with normal visual acuity could see at 200. 20, a normal visual acuity would see at 100. 20, a normal at 70, 50, so forth. And there's that famous 20/20, if you will. Okay, 20/20, that means you see at 20 feet what the person with average visual acuity also sees at 20 feet. 20/15, you see at 20 what they can see at 15, 13, and 10. The key to doing this is which line can you read without error, okay? If you get, like for instance, if you had 2, 4, 6, 7 of the 8 letters, but you missed the 8th one, you don't have 20/15 vision, all right? You would have 20/20 vision. That doesn't mean you can't see some things at 20/15, but you need to see it without error and without excessive difficulty, okay? People get real competitive about this or even defensive a little bit. The key is to appreciate what your visual acuity is. I mentioned this in class the other day that we are often very visually oriented as a young person in our lives. And the reason being is we want to look our best. We're putting our best foot forward. And I have seen and I do observe people who will refuse to wear glasses because they want to look good. There are several famous actresses who, when they are on screen, take their glasses off and are almost legally blind. So when they're doing their scenes, they really can't see anything. But because there is a perceived stigma of wearing glasses, they won't wear glasses, and they won't wear glasses to class, they won't wear glasses walking around. And that's not only detrimental to academics, it's also perhaps unsafe. You're talking about driving or doing something along those lines. But in any case, we have the chart here, and then we also have the chart over here. So this one's a black and white chart over in this corner. But again, don't close your eyes when you're doing the test. You want to keep both eyes open. You're just going to cover one while you're using the other. Also prefer that you do uncorrected. We want to see what your actual visual acuity is before correction. And if you find an unusual number, if something isn't quite right that you didn't expect, it might be a good idea to consult a professional about this. These yardsticks here are for measuring what we call accommodation. So with accommodation, what we're going to do is we're going to hold that yardstick right up underneath your eye. Okay, you're going to hold that right up underneath your eye, right on your cheekbone. And we have these little cards here that have teeny tiny little text. So find the smallest numbers you can see on here. And what you're going to do is you're going to start out, I'm going to do this, sort of simulate this. You're going to have that yardstick on your cheek, and what you're going to do is you're going to run that card from far away. Sorry, the focus isn't great here. You're going to run that card from far away, and you're going to bring it closer and closer and closer until it is no longer in focus. Okay? You're going to bring it closer and closer and closer until you notice that your eyes can no longer focus the letters and numbers, the really small ones, clearly. All right, that is known as your near point of accommodation. And, on average, a young person will be somewhere in the 10 to 15 centimeter range. Someone my age, it's a little closer to 35 or 40 now. I've actually watched it go. When I first started here at UIndy, I was somewhere in the 20s, and I have progressed out here into the 40s or so, and I do that with my cell phone now. So we have that for near point of accommodation. We have our tuning forks here. That's for Rennie's and Weber's test. That's for the hearing part of the lab this week. Please, please, please do not strike the table with these things, okay? It damages the tuning forks, and it also damages the table. Best thing you can do, just use your heel. And you want to listen for the low sound. You want to hear the low sound. You're going to do bone conduction with this, one side or another. Rennie's and Weber's test. Really, really powerful tests for diagnosing different types of hearing disorders. We often will do localization of sound, but we're not doing that this semester. So we're going to be doing Rennie's and Weber's tests and the ramification of that test, a very, very common clinical test. For the somatic senses, we have the 2-point discriminators here. I've got 3 of them. They are just nautical dividers, and what you're going to do is you're going to start with them very, very close together, basically touching, okay? And what you're going to do is you're going to progressively move them further and further out until the patient can clearly discriminate 2 points when they know it's 2. What you do is you just have them with their eyes closed, and you ask them, do you feel 1 or do you feel 2? Do you feel 1 or do you feel 2? And they really should feel 2 separate stimuli when they have hit that receptor, that 2-point discrimination. So we're going to do that experiment, and then we're also going to map receptor fields. We're going to be mapping receptor fields. You've got rulers here. You've got the sharp pins. You've got the blunt probes. And again, we're going to use the blunt probes with not the thin end. You're going to use the thick end. And again, straight down on the skin. Straight down on the skin, okay? Try, when you're doing this, see if varying degrees of pressure change any of the perceptions. That would be an interesting little side experiment. And over here we have a cotton swab, and what I have done is with the head there that's off the box there, we have teased out a little bit of the fibers, and that's what you want to do with your fine touch cotton swabs. I've got different colored markers here. These are water soluble. They're not permanent, so you can wash it off when you're done. But you're going to draw a little box on the skin, preferably somewhere that doesn't have a ton of hair. You can do it on that side, but the hair tends to interfere. So someplace like the inside of the arm is really, really good, where you can draw a box, and then you're going to test the 3 different stimuli: the sharp stimuli, the blunt stimuli, and the fine touch. The rulers here that we have are not only for drawing the boxes on your skin, but also for measuring the 2-point discrimination. So you've got those rulers for the receptor fields, and you've also got them for the 2-point discriminators. What else do we have? We have our water temperature, the thermoreceptor experiment. I've got instructions here, and what you're going to want to do prior to the experiment is on those outside boxes, you're going to put warm and cold water respectively. So follow the directions that are here on the table. Going to put some warm water, about 3/4 full, cold water about 3/4 full, and then leave the water that's already here. This is at room temperature. The warm water doesn't have to be super hot. It doesn't have to be super hot. It should be comfortably warm, like a jacuzzi or something that where you know it's warmer than your body temperature. That's what you're hoping for. Cold water doesn't have to be ice cold. It just has to be cold water out of the sink. It'll be cold enough and it'll do the job. And what you're going to do here is you're going to put one hand in each of the outer boxes. I can only hold one hand here at the moment. Again, you're going to immerse that whole hand and let it sit there for 2 minutes. But you're going to do both hands. So you've got your right hand over here. You've got your left hand over here in the cold water. You're going to let that go for 2 minutes, and then at 2 minutes you go immediately both hands into the middle water. And the key here is to note the sensation when you put both hands into the identical water. What are you feeling, and what are you feeling first? Do you notice one sensation faster than the other? I'll give you a little secret there. There are differential types of fibers that detect different types of thermal stimuli. Last thing, a quick reminder. Please do put everything back where you found it when you're done with lab. That way we minimize levels of disorganization and potential confusion. So thanks for your time today. As always, if you have any questions, feel free to reach out to me. I'll be glad to assist you as best I can, and hope you enjoy the lab this week. Thanks. Talk to you soon.